Isomers. We know there are two types of isomers, structural isomers and stereoisomers. But today we're going to be looking at structural isomers. Structural isomers are isomers that have the same molecular formula and different structural formulae, unlike stereoisomers, which have same molecular and structural formula but different spatial arrangement. There are four types of structural isomers. The first one is carbon chain isomers. Second one is position isomers. Third, functional group isomers. And finally, taumarism isomers. A chain carbon isomer. If you have hydrocarbon C4H10 from alkane, where N is 4, the structural isomer is the display isomer here, and this is the molecular formula. We can have more than one structural formula. That's another structural formula. Same molecular formula, different structural formula. And that's what we call structural isomers. If we try to name this is butane, and this is 1, 2, 3. This is 2-methylpropane. Or you might say methylpropane because 2 is the default. You can only have 2-methylpropane, so you might say methylpropane or 2-methylpropane. Another type of structural isomer of carbon chain isomer would be if you have C5H12, and that is an alkane of N equals 5, you have the first structure, which is pentane, 1, 2, 3, 4, 5. So that's pentane. You have the second structure, which is different from that. Same molecular formula, different structure. That's a structural isomer. And that's another structure. If you name this one is pentane, and this one will be 1, 2, 3, 4, or you might do 1, 2, 3, 4. So if I do 1, 2, 3, 4, or you might do 1, 2, 4. Well, the closest, the one with the smallest number will be the best one to use, which is 1, 2, 3, 4. So 2 is smaller than 1, 2, 3, 4. 3 is big. 3 is bigger. So we have to use 2. We have to start from here. 1, 2. 2-methylbutane. 2-methylbutane. What about this one? 1, 2, 3. Or you might do 1, 2, 3. There's no difference. And so this one is 2,2-dimethylpropane. So that'll be 2,2-dimethylpropane. Again, it's same molecular formula, different structural formula. This is a structural isomer. Another example is if we have C5H10, that's a structural formula. CnH2n, this will be alkane, that's a double bond, and this is structural formula. We can do another structural formula, another structural formula, another structural formula, another structural formula. Pent 1 in, because that's 1, 2, 3, 4, 5. Pentene, because it's got double bond, and the double bond is on the first carbon. That's the first carbon. 1, 2, 3, 4, 5. The double bond is on the second carbon. So that would be pent 2 in. The double bond starts on the second carbon. That's why it's 2 here. And in just indicates double bond. So we got another structural formula. So that's why it's 2-methyl. 1, 2-methyl. 1, 2, 3, 4, but 2 in, 2, 1, 2, methyl, but 1, 2, 3, 4, 2 in. The double bond is on the second carbon. Now let's name this one here. So you have to count from the left, not from the right, because the right is too long. 1, 2, 3, 4. So you have to count from the left. 1, 2, 3, 4. So that will be 1, 2, 2 methyl. You have to go for the longest chain, but 1 in. So that'll be 2-methyl, but 1 in. 2-methyl, but 1 in. What about this one? So you have to start from you have to count the longest chain. 1, 2, 3, 4. So that's but 1, and the methyl will be 1, 2, 3, 4. So it will be on the third carbon because the functional group is the in. So you have to start from the functional group here. 1, 2, 3. So that'll be 3-methyl, 1, 2, 3, 4, but 1 in. 3-methyl, but 1 in. Another example is to use the C6H12. C6H12 cycloalkane CnH2n. That's the general formula for the molecular formula. Cyclohexane another structural formula. That says cyclopentane. Let's give it a name, cyclohexane. And this is a closed system. And it's pentane, so cyclopentane, because there's 5 of them, but it's got 1 methyl, and that's 1, 2, 3, 4, 5. 1 methyl cyclopentane, or just methyl cyclopentane. 1 methyl cyclopentane is position isomer. So we just done the carbon chain isomers. It says only carbon chain isomers. So that's our carbon chain isomers. Now we're going to do second one, which is position isomers. So again, it's indicating the position of a substitute. Here's an example. A molecular formula, one structural isomer, another structural isomer of the same molecular formula, but different structural isomer. That's what a structural isomer is. That's another one. That's another one. So this is 2-bromobutane, 1, 2, 3, 4. That's but. So you start 1, 2, 3, 4. So that'll be 3-bromobutane, or 1, 2, 2-bromobutane. You have to go for the 2 because it's the smallest number. What about this one? This is 1-bromobutane, or just bromobutane. 1-bromobutane, or you might just write bromobutane. This one is 1, 2, 3, 1, 2, 3, or 1, 2, 3. 2-bromo, 2-methyl propane. B comes before M. So B comes before M, 2-bromo, 2-bromo-methyl propane. Another one is, or you might say 2-bromo-methyl propane. 2-bromo, 2-methyl propane. So you count 1, 2, 3. So that'll be 2-bromo-methyl propane. Or you might say 2-bromo, 2-methyl propane. What about this one? To count the longest chain, 1, 2, 3. So that'll be 1-bromo, 2-methyl propane. 1-bromo, 2-methyl propane. Or you might say 1-bromo-methyl propane. Functional group isomer. Again, you've got a general formula. Here's a functional group, carboxylic acid, 1, 2, that's ethanoic acid, ethanoic acid. And that's another functional group, methyl methanoate. So that'll be methyl methanoate. So that's one functional group, and that's another functional group, hence functional group isomer. Same molecular formula, different structural formula, structural isomer. The final example is tautomerism isomers. Here is a 1 ketone here, and that will be converted from ketone to enol in an equilibrium. So that's enol. So that's ketone. Ketone means an R group, and a carbonyl compound. So this one is propanone. That's enol. This is an enol, and that's a ketone. Keto and enol. Keto and enol. So this is acetone. That's a chemical formula for acetone, which is also called propanone. And this one is pronounced as propene, 1, 2, 3, propene, because of the double bond here. Well, the double bond is on the first carbon, so you have to count 1, 2, 3, 1, 2, 3. But the second carbon has an alcohol group. So propene 2-ol, 1, 2, 3, propene 2-ol. The ol is indicating alcohol. Enol. Do that again. Enol. Ketone. Keto to enol. To summarize, we have isomers, and there are 2 types of isomers: structural isomers and stereoisomers. Structural isomers have same molecular formula, different structural formulae. Stereoisomers have same molecular and structural formula, but different spatial arrangement. But today we're focusing on structural isomers. There are 4 different types of structural isomers. The first one is carbon chain isomers. The second one is position isomers, which means the position of the functional group matters. And the functional group isomers means you can have different functional groups. That's one functional group, carboxylic acid, and a methanoate functional group, And the fourth one is tautomerism, where you have an equilibrium between the keto and enol. So you have propene 2-ol in this situation. Prop means 3 carbons, 1, 2, 3. In is indicating double bond. 2 is on the second carbon. Ol, it's an OH group. Enol. Enol, that's enol, enol, ketone. Ketone has a carbonyl group with an R group and R group. Same molecular formula, different structural formula.